Number 1, a local utility company wanted to gather data on the age of air conditioners that people have in their homes. The company took a random sample of 200 residents in a large city and asked if the residents had an air conditioner, and if they did, how old it was. Below is the distribution in the reported ages of the air conditioners. So below we have a histogram, a relative frequency histogram, of the ages in these air conditioners. Describe the shape of the distribution of air conditioners. Explain your answer. So if we were to describe the shape of this, we want to see if there's any skew or if it's mostly symmetric. So if I was to draw a curve around this, we see that this is an approximately symmetric distribution. This distribution is approximately symmetrical. It's symmetric about the mean, but both of that right tail and that left tail are basically the same. I think you could argue that there's a slight left skew, but if you explain that the left tail is a little bit longer than the right tail, you wouldn't be incorrect. But this is symmetric enough for me. So explain your answer. You should say something about the right-hand tail and the left-hand tail are approximately equal in length. There's no strong skew in either direction. It's also mound shape. It has that, most of the data is in that middle part. Is the mean of the age distribution closer to 15, 20, or 25? So the mean, the average, is a measure of center. The mean is a measure of center, so I want to know what's the middle of this distribution. What's the balancing point of this distribution? So if you ask me to describe the center, I have options of 15, 20, or 25. Is 15 the balancing point? Can I balance the distribution there at 15 years old? No, clearly that would be off balance. 20, could I balance this distribution at 20? That looks pretty good. The other option, I believe, is 25. That's clearly not the center of the distribution. That's not the center. So I think your best bet would be 20 years old. I'd say 20 is the center, 20 is the mean. I would say the mean equals 20. Why? Because it's the center of the distribution. Because it is the center of the distribution. Where that extra letter came from there. Distribution. So the mean is a measure of center. It tells us where the typical age is. So the typical age, I would say, is about 20. Is the standard deviation of the ages of the age distribution closer to 3, 6, or 9 years? So standard deviation is a measure of spread. It measures the variation in our data. And the standard deviation is the typical distance from the mean. So am I normally 3 from the mean, 6 from the mean, or 9 from the mean? So our mean is 20. What's a typical distance from the mean? If I go up 3, that brings me to 23. Is that typical? Or should I go up 6 to 26? Is that typical? Or over here to 29? 9 is the most ridiculous one. No way. 9 is bigger than the entire... 9 is more than half the distribution's length, so no. 6 is a little big. 6 captures most of the distribution if I went up 6 and down 6. I wouldn't call that typical. I'd say the typical is 23. I'd say the typical is 23 because that captures that middle portion. If I draw those bars in there, that's 17 and 23. That captures the middle, that represents the typical measures around that center. So I'd say the standard deviation is 3. And you can explain how you got that. That if I go up 3 and down 3, that represents the typical measure of the distribution. 6 and 9 are too big. On the histogram, mark 1 standard deviation above and 1 standard deviation below. Well, guess what? We already did that. I went up 3 to 23, and I went down 3 to 20 from the mean to 17, and that middle portion there represents 1 standard deviation within the mean. I went 1 above, 1 below. Number 2, the histogram below shows the distribution of the number of automobile accidents per year for every 1,000 people in different occupations. Describe the shape, center, and spread. So in stats, when we look at distributions, we need to be thinking of these 3 components: shape, center, and spread. So shape's important. Shape's important because we like dealing with symmetric things. So if I was to draw a mound above this, I get something that looks like that. If I was to draw in that distribution there, I'd say this distribution is pretty symmetric. Is it perfectly symmetric? No, you're never going to really find a distribution that is like that. So I'd say it's approximately symmetric. I didn't see any major skew going on there. Describe the center. The center of the distribution is important because that tells us the typical. What's the average? What's the typical number that represents this entire distribution? So the average is the balancing point. It's going to be towards the middle. I'm going to say it's around here, maybe at 89. I'd say 89 is a good balancing point. If you pick something around 89, you're right. I don't know exactly what it is because I don't have the data, but I'm going to say it's approximately 89 accidents per 1,000. Because that's the mean. The mean is a measure of center. The spread, how do I measure spread? Well, in our case, we're going to talk about standard deviation. What's a typical distance from the mean? Where do I capture about that middle chunk of the data? Let's say 97. So if I'm at 89, that's plus 8 to 81. I would say this little zone here, maybe you can go a little further out. Maybe you could include 101. But I'm going to say the standard deviation is about, I went from 89 to, I can't see what I marked off there, to 97. So I'll say the standard deviation is about 8. I'm going to say the standard deviation is about 8. How did I get that? I just estimated it. I said that captures about that middle chunk of the data there. So when we describe distributions, we want to be thinking about shape, center, spread. We like dealing with these symmetric distributions. You don't want skew. You don't want a skewed distribution like one of these two here, where you have a skewed to the right or a skewed to the left distribution, where that one tail is much longer. There's much more spread and variation in the data. Most of it's chunked in one side, and then you have that skewed going out. And finally, number 3, the histogram below shows the distribution of heights to the nearest inch of 1,000 young women. So it's a relative frequency histogram, so this is representing percentages here. The mean of this distribution is 64.6, and the standard deviation is 2.75 inches. Interpret the mean and standard deviation in this context. Well, the mean, x bar, is 64.6 inches, which means the typical height of a female, of a woman, is 64.6 inches. The mean measures the typical height. It's the center, it's the balancing point of that distribution. Our standard deviation for our sample is 2.75 inches. So the standard deviation, the big idea for standard deviation is it's the average distance from the mean. The typical distance from the mean, on average, is about 2.75. So the typical distance from the mean of the heights of women is 2.75. So the standard deviation is a measure of spread. It tells me what's the average, what's the typical distance from the mean. Mark the mean on the graph and mark one standard deviation above and below the mean. Approximately what proportion of the values of this data are within one standard deviation? So I need to mark 64.6. So I'll call that 64.6. We'll call that right here. That's my mean. That's my x bar in green. If I go up 2.75 from that, if I go up 2.75, where does that bring me to? Well, 64.6 plus 2.75 is about 67.3. So we'll call that there. That's one standard deviation up. And what if I go one standard deviation down? That brings me down to 61.85, so about here. So these bars here are representing one standard deviation within the mean. One standard deviation of the mean is represented by those bars right there. What proportion of the data? So this is about 10%. So this bar is about 10%. This bar is about 13%. This bar here is about 15%, 14, 12, I'm seeing the relative frequency, and let's include this entire bar of 11. So if I was to add all of those up, if I was to do 10 plus 13 plus 15 plus 14 plus 12, no, let's not include that 11. Let's not include that 11. Let's not include 11. We get 64%. Let's go right there for the sake of that. We don't want to include that whole bar. So there's about 64% of this data within that one standard deviation of the mean. That was lesson 1 about describing shape, center, and spread of distributions. It's going to be a big idea that's going to follow us through, is that we like talking about this shape. Hopefully it's approximately symmetric. The center is normally the mean that we're going to talk about in this course, and the standard deviation is going to be our measure of spread.